So hey guys, so we are back with another episode of the ML news update that happens every week. This time I was not able to bring you the episode as usual like on Monday due to some reasons. Actually, this week was pretty busy. I was busy in some my office work, and then there was some function at home. So apologies for bringing the episode late, but yeah, we are back with a bang. So let's start. So the first news is this artificial analysis.ai. A bunch of cool guys actually release this awesome website where you guys can go and compare all kinds of model. Believe me, almost all kind of model. You can compare their quality, speed, pricing. Then you can also go compare by the capability, that is general ability, reasoning and knowledge, coding. The best part is, you can compare these things all side by side. Now if you see at the prompt option, you can see the you can look at like single, multiple. If I do apply, then it is going to change accordingly. If I do single, it is going to change accordingly. Now if you see here at the current results, cool, it got updated right now on multiple. I'll do that single once again. So if you see a Cloud Opus, okay, their website, yeah, Cloud Opus is currently the most expensive API right now in the market, with what they say one of the best results, 98. But the point is, they are almost four times more costlier compared to GPT-4o, even though GPT-4o is given 100 on the quality index. So yeah, that's the case. Now if you look at the quality versus output speed, you will see that a lot of models are ranking differently. GPT-4o turbo is good. Quality, speed, quality versus price, if you see, even in that case, Cloud Sonnet and GPT-4o stands good. And if you see at the output speed, right, output speed per tokens, Gemini 1.5 Flash is the highest output tokens per second. That is 169 tokens per second. Pretty fast, right? And Llama 3 8 billion is 124 tokens per second. Groq, we have a lot of news for Groq. It's the most awesome thing that has happened when you see it from the point of hardware for LLMs. Believe me, one of the most awesome thing. Now, if you look at the output plus versus the price, Llama 370 billion, you will see that Groq is so better compared to all the other existing one. Amazon Bedrock, Microsoft Azure, Perplexity, Together.ai, Deep Infra, all of them, and then there is Groq. So you will see. Now let's see output speed over time, guys. If you see here, the output speed of Groq is starting from 223 and it's going at max till 334, I think. And just look at the other guys; they are not even close to Groq. So no doubt Groq is the best in the market right now. And you can see information of our supported models, everything. You can do any kind of analysis here. You can compare API providers, all of them. Then you have speech to text, text to image. Even if you want, you can compare through this all image arena. And then you have the quality LO score of each model in image arena. Higher is better than the generation time, pricing. So yeah, guys, so it sounds really good to me right now. That there is one place where you can go and compare all the things. Then you have all the leaderboards here. So right now the page is not obviously not that good as I was expecting. Now if you go to models, here is the leaderboard. The context window is here, index is there, blended, median, the first chunk, token per second, everything. So you can go and compare all the things here. Now this is something that has happened after a long time. Comparison website taking more credits than rest of the existing models. So yeah, cool. The next thing is Groq. I wanted to talk about this from a very long time. So this is their quick start page. If anyone has the APIs, you guys can go and use. So I use this for some company work, and believe me, guys, Groq is so fast. It's even faster than, I will say, GPT-4o right now. Maybe similar to GPT-4o, but to be honest, I found it faster. At least to GPT-4 is much faster. So what I did is I was working on some synthetic data, and I used their Groq API, which my company provided me for some testing purposes, and I used that, and I was sending at parallel 20 requests, and it took 3 seconds for generating all the answer. 20 requests, 3 seconds, and all of them were more than 200 tokens, I think. So that was pretty fast, right? For a model like Llama 370 billion, it's pretty fast. But when we are comparing it with GPT-4 or 4o, we need to consider the case that obviously GPT-4 and 4o are much bigger model. 4 is, I think, more than 500 billion parameters. So obviously it's not a fair comparison, but at last results and speed matters. Not everyone looks at the parameters when you look at the speed, right? Now, this is Groq book. Some guy named Bicky Lieger. I am so sorry. So I think Benjamin Lieger. I think this is a much better way to pronounce his name. So yeah, he has even created this Groq book stream.streamlit app. So generate entire books in seconds using Groq Llama 3. So it's a streamlet app scaffolds the creation of books from one line prompt using Llama 3. So you guys can literally generate the whole book using this. I would recommend you guys to go and give this guy a star on this, because the work he is doing is awesome. Because you guys can literally use this API to by entering your Groq API obviously, and you can generate a whole book using this. He has already put some prompt there, and to be honest, Groq is so fast that happening all of these things within seconds is not to be surprised, right? So don't be surprised if you see things going pretty fast. Similarly, then you have Groq Notes, same guy, and generate organized notes from audio using Groq, Whisper, and Llama 3. So he has integrated all of those things. Just imagine, he is making life easy for a lot of us if we already have the current API versions and the credentials for accessing that API. So this is Groq Notes. So generate organized notes from audio in a minute. So looks good, right? So again, do give this guy a star here, because he deserves that. Now, coming to the last part, which is research papers, the favorite part. So let's start with the first research paper that we have for this week. It was released on 5 July. I know, bit late, but yeah. So this paper introduced a concept of test time training layers. So we know about RNNs. We have not talked about our RNNs, right, from a very, very long time. So this is a new class of RNN based sequence modeling layers. So these use self-supervised learning to update their hidden state during test time. Now these layers, that is TDD linear, then we have D MLP, the address the limited expensive power of traditional RNNs, right, while maintaining the linear complexity. So if you look here, right, you'll be able to see that TT linear and TTD MLP outperform strong transformer models and modern RNNs like Mamba. Now if I took you some results, you'll see here, right, you'll see there the TDD linear and the TTD, if you see, are the transformer and Mamba. So additionally, these layers demonstrate efficiency improvements, making it faster than the transformers at certain context. Remember, certain context, and competitive with Mamba in wall clock time. So this particular paper is actually highlighting this test time training layers potential, and calls for further research to tackle open problems and optimize the performance. So someone talking about RNNs after a very, very long time, I feel really happy. And if you look at the initial state, update state, they have mentioned everything. So it's a very good research paper. I can't talk about this research paper in detail right now. It will go on for 20-30 minutes. So in a nutshell, I've given you guys a brief, so you guys can go and read this. Cool. Coming to the next research paper, that is the searching for best practices in RAG. This paper is really good because I personally work on RAG a lot, and this paper talks about a lot of things here, a lot of things. There are 5 to 6 major things in RAG, right? And this paper has tested every possible case in that and then has compared it. So at final conclusion, I'll show you the final conclusion so that you guys can go and read the paper research. And yeah, so if you see here, right, they are saying for the current part, right, they are using the rank llama is suitable for achieving the best performance, at least what they are saying. And yeah, this is the final results, right? These are the final results. So you can choose accordingly, whichever is best for you. What they recommend, based on the experiment results, the following key sets: query classification module, right? Then you have the retrieval module. They are saying hybrid with height, that is hypothetical documentation embedding, right? Then for re-ranking module, they are saying Mono T5. The repacking module, they are saying the reverse configuration. They are saying summarization module, they are saying that recomposition demonstrated superior performance. So this is the best which they are saying. So this paper actually tells a lot of things. Even I think they have done some comparison on the chunk size. Yes, chunk size. So 512 gives you the best results. Similarly, which is the current best database? Obviously Milbus, we all know, but why? So the results are here. It's one of the best paper for RAG survey that I have read in a very long time. So yeah, a very good paper. I will recommend you guys to go and read about this. Now the third paper is RouteLLM. So This is a framework that uses router models to dynamically select between stronger and weaker language models. Now you must be thinking, so what is happening here? We are selecting between what is a stronger model and weaker language models during inference to balance cost and performance. By leveraging human preference data obviously and data augmentation techniques, the proposed routers optimize query routing, right? So we are doing some query routing. If you look here, right, routing performance trade-off between GPT-4 and Mixtel 8 7 billion. So they are telling that, right, that by leveraging human preference data and augmentation, right, the proposed routers optimize query routing, significantly reducing cost by 2 times. Just imagine $30 to $15 without compromising response quality. So they are going to decide the router models are demonstrating strong transfer learning capabilities, maintaining performance even when the language models are changing at test time. Just imagine. So evaluations on benchmarks and MMLU, I will show you the results. The results must be here. I'll zoom out. Yes. So if you see here, the DRNA and the DJudge. So if you see the routers for both matrix factorization router and similarity weights ranking output. So you see matrix factorization, right? 25%. This is, and here it's 58% the SW ranking. Similarly, matrix factorization when it comes to DJudge, it's better. Now, if you guys don't know about this, I will recommend you guys to go and read this paper, because they have telling in detail that how you can use this particular framework to reduce your cost and even improve the efficiency, keep the efficiency as you have right now. So why not? This is the page, RouteLLM, an open source framework for cost effective LLM routing. So yes, paper looks interesting. Second last paper, this paper introduces PE-rank, leveraging passage embeddings for efficient list-wise re-ranking with large language models. Sort of similar to RAG, things can be used in RAG a lot. So the list-wise approaches such as Rank GPT have become new state of the art in this task, right? So what we are doing in passage ranking, right, that this passage is better. So unlike traditional approaches, that face limitation obviously in context length like GPT and high latency, you are every time calling a big model for just a re-ranking. PE rank treats each passage embedding as a special token, reducing the input and accelerating the decoding process. So what it is doing, it is treating each passage embedding as a special token. So the method employs dynamic constraint decoding and then list-wise learning to rank loss for training. So evaluation on benchmarks they have done, like I think they did on TREGL and then they did on BEIR. So I think the results were pretty good. So this is the architecture if you see here, right? So there are two stage, a retrieval stage, retrieve and passage embeddings, and this is the forward pass procedure of LLM. And the third is obviously shows the list-wise locator. They are telling that thing. So these are the two steps, right? One is happening here, then one is happening here. Cool. So yeah, that was it. And if you look at the results, yes, if you look at the result, PE rank. So this is that NDCG, they are getting good results, and they have even rank Mistral, right? So results look good. Now if you go down here, yes, even in this case, they are able to outperform the GINA the GINA embeddings, the BG base. BG base are used a lot, guys, a lot. So yeah, cool. I think we are done for this paper. The last paper is scalable MATML free language model. It's a very good paper. I think even few YouTubers like Kilcher also talked about this model, this paper, and this paper is pretty backward, like 18th June 2024, but it's worth it. So I'll do this as fast as possible. We'll try to keep the video below 15 minutes. So they are telling a method to eliminate the matrix multiplication operation in the large language models while maintaining strong performance. Yes, they are eliminating the matrix multiplication operations in the LLMs. Now they propose this MATML models to models use additive operations in dense layers and element-wise this header merged products for self-attention. So it's quite complicated, the mathematics that they have done. Even when I was going through it, a lot of things went out of the head. Then I watched few videos, few mathematical things, and then everything started making sense, right? So this approach reduces computational cost, obviously, memory usage and latency, achieving performance comparable to state-of-the-art transformers. So the authors provide a GPU efficient implementation also and a custom FPGA accelerator. At least that is what they call it. And so what is this whole paper doing? It's highlighting that we don't need matmul. Without even that, the multiplication operation, we can achieve the same accuracy with some same thing happening at the back end, getting the same results, the mathematical operations, right? So yeah, guys, that was it for this week. I think I've wrapped up almost all the things. Meet you guys in the next week. Thank you and have a nice day.